All right, this is FRQ number 26. I would like you to look at the table and I would like you to answer A in its entirety. Okay, let's take a look at A. It says if the function f of x is an exponential function that models the data in the table, what can be assumed about the value of B? Explain your reasoning based only on the information given at this point. Hopefully you guys were looking at the y values when we're looking as x is increasing, what is happening with those y values? Well, they are also increasing, which means it's going to be a growth function. So the data in the table shows the number of bacteria population is increasing, which indicates growth. Since x is greater than 0, which is given, right? So there's no reflection there. And the y values are positive, which means no x-axis reflection. There are no reflections, so b needs to be greater than 1. On B, I would like you to use this equation as the regression equation and use it to find the value of f of 20. And then in the context of the scenario and using correct units of measure, explain what that value represents. Okay, so what we have, if we were to just plug in f of 20, if we were to make x 20 and evaluate that in the calculator, this is what you would get. Go to 3 decimal places. However, in the context of this scenario, this is what you would write. At the end of day 20, and I say at the end because in the table, it does say that the number of bacterial organisms present in a culture dish at the end of various days of an experiment. So at the end of day 20, there will be 3,070 bacteria in the dish. Okay. All right. So on C, what is the initial population of the bacteria in the culture dish? Show and justify your work. Okay, so this is the equation that we started out with. And this is what we're going to end up looking at. So f of 0 will indicate the initial population. There is no 0, so we need to figure out what number that would be. And if x was 0, then my initial population would be 112.097, which would just simply be 112. And then on part D, go ahead and answer that question. It says when the bacteria in the culture dish reaches a population of 700, an antibiotic is going to be applied to kill the bacteria. On what day will the antibiotic need to be applied? Show and explain the analysis that leads to your answer. So we are given this function right here, and we're looking for the number of days where it will take to reach 700. Okay, we need the 700 population. So what we're going to do is have to find x. So whenever we are solving for an exponent, we need to use a logarithm. But before we can do that, we kind of need to isolate this guy all by itself. So what we need to do is divide both sides by the 112. And then what we have is this 1.180 to the power of x is equal to that amount gave us here. Then we are now allowed to bring out the x by taking the log of both sides and then simply dividing both sides by log of 1.180. And so you end up getting x is equal or approximately 11.067. So remember the question was on what day will the antibiotic need to be applied? Well, it's a little over 11 days. And it's not like I can go into the doctor's office at like 11 days and 3 hours and 2 minutes. So what would make sense in the context of the problem is that we would need to have the antibiotic applied on day 12.